Welcome you all for this course on XSF in RP 2019 chemistry. We will take a case study today. First let us open the WinGX program. Sir, it is not coming on screen? Yeah. Okay. So, now when you open the screen, there is a file called here, go to project, select. Now, browse the work folder, either you can choose zip or INS or REST file, which is here. So, let us choose the INS file. Now, this is come here, that is the INS is here, then open. Now, I will go for the Wilson scaling that we have discussed, go to E statistics in preliminary. Now, we can see the Wilson scale. Here what you can see is you are getting a scale factor and the temperature factor. Here what you get here is U mean is equal to 0.064 comma the scale factor is 28.157. Now, this is for the given molecular formula. As already we have seen in the Wilson plot, in the x axis natural logarithm f observed divided by the f observed square or I divided by the sigma f square, what is given from the molecular formula calculated. Then the x axis is sin theta by lambda square. Now, the star shows the data what is collected, that is the intensity ratio and the sin theta by lambda versus. So, a best fit is plotted and it calculates the temperature factor, nothing but U mean and the scale factor, this 28.157. Now, we will go to this one, we will open the INS file. This is a solid structure. Now, what I am saying is here you can see the first line is the title, here is the title, then second line gives you, here is your lambda and A, B, C, alpha, beta, gamma. This is a monoclinic system which is specified P1 by C, and Z and error. Z is number of molecules in the whole unit cell, and this is the standard deviation X, mean A, B and C, then alpha 0, beta you got the standard deviation gamma 0. Then lattice is 1, for primitive it is 1, for C centered is 7, okay, plus is for centrosymmetric, minus is for non-centrosymmetric. Then symmetry element, here x, y, z and x, when I give centrosymmetric, x, y, z and x bar, y bar, z bar is understood because no need to give x, y, z. The other two equivalents here is minus x, up plus y, up minus z. We know no need to give the inversion related, there is x, up minus y and up plus z. Then comes the molecular formula scattering factor. Here the elements expected is maybe C, H, N, O, S. Then the unit is number of atoms in the whole unit cell, multiply, that is molecular formula multiplied by 4. Then merge this to merge equivalent fraction, number of cycles least squares is say 4, actor will create the zip file, then bond conformation, all this thing. Now, let us see, we do not know the molecular formula, it is expected, let us see, copper, Cl. Okay. So, copper is say 4, Cl is 8, it is perchlorate, then that case 4 plus 4 8 into 432. So, it is 48. Now, let us go on to see the Wilson plot. Now again I go to this one and this is the Wilson plot E statistics. Now you can see here what has happened is, you can see U mean is coming (0.063) and K is equal to 117.319. You can see the values difference here is 28 and is 117 because the molecular formula is playing a major role. Okay. Now let us solve this structure. Now we can come here. Now we can determine this phase group, assign phase group. Okay. Now it is very clear it is monoclinic, so select monoclinic. Okay. Okay. So the program is chosen, monoclinic space group. Okay. Close. Now come here and you can solve this structure either by direct methods. Okay, or let us see the Patterson, whether the heavy atom is present or not. Go here, select 36, then Patterson. Now we can see this is the structure, what is coming here. Quit, come here, then open it in the RS file. So you can see here, you can rotate along the x axis, y axis or x axis. Okay. Now if I put show label, now you can see this is copper and this is our Q1, Q2 unlabeled atom and here is the fragment. Okay. Now what we can do is, let me try to identify the molecule, what is present here, exclude the center one, enter, exclude this one. Now I can see a ring is formed here and here I can't make out anything. Now the next question is, I will just go here and again solve it in direct methods and see the heavy atom. So here you can see from here, this is the REST file, the output file. You can see the inputs, what is given, cell dimension A, B, C, alpha, beta, gamma, and volume is calculated for the given molecular formula for the cell dimension. And here you can see that the statistics, E square statistics, centrosymmetry is 0.968 whereas acentric is 0.736. The data shows that it is 0.95, 1.0, 9.98, 0.98, that is 0 KL, HOL, HK0. This is all data which is close to the centrosymmetric. So, the structure is confirmed centrosymmetric. And here are the phase determinations and all the semi-invariant, all this thing. We can see now for the best solution, it has got the molecule like this, a 6-member ring and something is here. Okay. Now, these are the atom positions in the order. Now, you can see the first atom is 429 peak height, immediately there is a drop here. It goes like this and this is the matrix table. It means 1 to 13 is 1.7, 1 to 16 is 1.72. Now, the angle is 13, 1, 16 is 88, or 13, 1, 20 is 84, means 16 is 84, 13, 1, 20 is 134, like that. So, it goes like this. Now, we will close it, we will open it in the camera. Now, this is the structure what is appearing. Here I can't make out what is this thing. Okay, let us try to make rename, maybe carbon C1, C2, C3, C4, C5, C6. Now, there is a branching, okay, maybe it could be N1, N2. Okay. Now, these things we do not know, I will exclude these things, the higher peak height. Now, I can see something like a 6-member ring and a 5-member ring. Okay. Now, we do not know what it is. So, it is better to go along with the known molecule fragment, exclude Q's, En, and close it. Now, go here, open, this camera dot out. Okay, so this is what is being obtained. Now, this is a scattering factor, but need not be given this way. We will modify this H N O S C U C L. So, we can remove this thing, delete. Now, you can see that C1, N1, this how it has been labeled. Now, C is 1, H is 2, N is 3, O 4, sulfur 5, copper 6, chlorine 7. So, N should be 3. Now, we can introduce this L dot S dot the D square, say 4 cycle, then F map Fourier 2, number of peaks to be plotted, say 25. Okay. So, L dot S dot F map to plan 25. Okay. Now, we can save it as INS. Now, continue for refinement. Now, we can see the R factor is around 63%. Okay. So, let us see what is the map. Now, open the res file. You can see the Q peaks. Okay. These are the peak heights, electron spectrum cube. These are the input atoms. Now, we will close it and plot it. Now, we are not getting anything meaningful. So, the question is now, whether the perchlorate is there or not. Okay, then we will remove it. I will remove these two. Respectively. Now, we can save it again. Now, we again solve it. Okay, here now you can see that 2 rings are there. Now, let us plot it here. So, now we can see that this is the structure expected, but which is not very clear. Now we will go to the shell X. Let us check the INS file. So now we can see that there is a 5-member ring and there is a 6-member ring here. Okay. Okay. Now it is a bit clear. Now let us see show label. I will remove the higher peak heights, exclude maybe 21, 20, 19, 22, 18. Let us see what it gives. Okay, so now I can see this looks better. Okay, I will rename it. Now while renaming it, it should be renamed in the order. So this is expected to be O1, C1, C2, C3, C4, C5, C6 and is N1. Enter, redraw. Rename C10, O11, O12, C13, C14, C15. Enter. I do not want these two peaks. Rename. So 15, 16, C17. N, close it. Now I renamed it. Now it is better to arrange them in the order. Okay. So again H, N, O, S. Here we got a sulfur in the molecule as per the expected molecule formula. Now introduce L dot S dot 4 F map to plan say 25. Now you can see CO is 4, N is 3, again this is 4, this is 4. Okay, now let us save it. Save as NS. Now refine. Now one can see the R factor has come to 50%. That means there are some more peaks we do not know. Let us see the S file or the new peak. Now we can see there is a strong peak appearing here. 14 electrons or 15 electrons per angstrom cube. Now let us plot. Okay, exclude Q's, include Q1 and Q2, the higher peaks. Okay, so now let us see whether this could be a sulfur. S1. Okay, then N, exclude Q's, N, close it. Again open, camera on. Okay, sulfur is 7. Again save it. Close, then refine. Now one can see the alpha has come to 16%. Now let us see any more Q peaks. So this is only one peak Q1, otherwise everything is fine. Now what we will do is we will plot it. Exclude Qs. Now I can see this is the expected molecule. Okay. Now it should be renamed in the order. So I will put it this way. This is S1. So here I given C1, C2, C3, C4, C5, C6, N1, O1 and 10, So, this should be C11, C12, C13, C14. Okay. So, now it is in the serial order, then end it, close it. Now, it is better to rearrange the atoms in the beginning, it becomes easier. I will open the camera. Now, it should be usually in the decreasing order of the atomic number. So, sulfur will go to the first thing, control V, then control X, here comes oxygen O1, then I will separate it, maybe control X C1 V, control X C2 C3, control X C4, control X C5, then comes N1. Now, you can see here O1 to C6 belong to the first molecule, as sulfur goes second molecule. So, I will do one thing, I will take this thing there. I will group it this way. So, now it is 10. Now, it is in the order of the molecule. Let us save it. INS file, then close it, then refine. Now, it is around 16%. So, it says extinction correction or solvent. Now, plot it. Now, you may remember, show label. So, we group this molecule together and this molecule together. Now, you can see that there are a lot of Q peaks on every atom. In addition to this one, you can see this and all 19, 18, 15 are hydrogen, here 6 hydrogen, then Q12 and Q22 hydrogen. Okay. Now, let us do one thing, let us do anisotropy and see that. Open this file, introduce the command anisotropic. That means all the atoms will be done anisotropically. Now, saves INS, close it, then refine now. Now, you can see the R factor come to 8%. Now, it shows extinction of solvent, but here when you plot it, is there any solvent atom? No, because there is no Q peaks. These are a very low peak height. Now, plot it here. Exclude Q. See, now you can see that there is no solvent molecule. So, it is only an extinction correction, no need for a solvent correction. Now, let us introduce the extinction correction. Let's file, introduce EXTI. So, it will use a default value and start refining. Refine. Now, you can see the command, the alert has disappeared. Now, let us see the Q peaks. So, there is no Q peak, all are less than 1 electrons per angstrom square cube. So, let us plot it. Now, I can see that the additions are appearing. Now we have to rename it, rename the respective order. This is say C3, so it should be H3. Then this is C4, so it is H4. This is C6, H6, enter. Okay. Then the other peaks we can remove it for clarity. Okay. So what is expected here is this is NH2, so this is N1. So rename H1A, H1B, enter. Then here again we can resolve it. We will remove these peaks. Okay. So now here I can see that show label, rename H13, H14. Okay. Now explore QPX. Now we have to identify atoms in the correct way, the element wise. Now let us see in the 6-member ring, let us go to sorry. Now we can see that there are some thermoellipsoids which are smaller and bigger. Okay. So here is the N, then this should be N. So C6 could be N. So rename N6, enter. Sphere. Same thing in this one, here COO, then expected is this is supposed to be N. Rename N12. Okay. So sphere, exclude Q's, end, close it. Now open it. Now the additions we can rearrange it later. Now save it as INS. Then refine. Now we can see the R factor has dropped drastically because some elements were wrongly identified earlier. Now again you can see the rest file. So no QPX, only H6 is having high temperature, but let us see what it is. Okay. Now as anything is new, let us check here. Now you can see that for this carbon C2, H is missing. Okay. Okay, this is for C6, C2. So that means rename H2, enter. Now everything is identified, end, close it. Now open. Now the additions can be or arrange the order. H2 should go up, Control X, Control V, 3, Control X, 4, then Control X. Okay. Now save it. Now continue refinement. Now you can see here the maximum shift will be coming here. That is, you can see the maximum du for the last cycle is this much for hydrogen atom. Now this you can see from the summary. Here you can see the shift over ESG maximum is 0.00, R factor is 0.043, and the residual peak maximum is 0.279. Okay. Now we will open REST file and see these things. Okay. So H2 shows bit negative. So what is this H2? So this H2 is a wrong one. So exclude H2. Enter. So let us try to relocate. So there is no proton here. Then what it is? Let us see ellipse. So it shows very low. So C2 could be again N. So rename N2 and close it. Okay, now save it. Exit. Now refine. So the R factor is dropped to 0.46. Now plot it. So this is the structure, what is expected, ellipse, everything looks fine. Okay. Now you can see the packing using a Mercury diagram. Okay. Now you can see this molecule here. Now there are different sides. Okay, you can see down A. Display. Okay. Now you can see packing. Now you can see down A or down B or down C. Okay, down B looks better. Then we can see the label atoms. Okay, or we can see the hydrogen bond. You can see how this packing, just you can expand it. Now one can discuss the nature of hydrogen bond, what is. So there is a dimerization here and this is like a chain. Okay. B axis, or A star, B star, C star. Now you can go to the slicing, adjustment, remove it, or you can go to the style here. Characteristic could be like this. Or it can be even ball and stick, or one can go for the space filling. This is how it looks like, or thermal ellipsoid. Okay, then you can plot it. You can go for display, color, background. You can make it single color like white. Now you can plot it for the publication or things. Okay, now just go back. Close it. So this is the packing diagram. We can talk about all those things, or one can go for the art step. Just click here. Okay, it's not working. Now we can go here. You can create the past one. You can see this. All these coordinates. So here what you can see here is these are the cell dimensions, ESDs, and the nuclear matrix, and the coordinates which a fraction position. Then this is nothing but the orthogonal coordinates. Then this is a displacement UIJs. Then the principal axis thermal ellipsoid and bonding to bonding. This is uncorrected. Lower bound, upper bound, riding motion, and non-corrected. So this one can use it. Then comes the bond angles, it's the ESD here. This is the torsion angle, and the interatomic contact distance 4 angstrom, and this is intermolecular contacts. Then one gets the argument. This shows the donor proton acceptor is C14O12. You can see whether this is acceptable or not. Okay, so one can choose all these things. Now we can open the zip file, what it contains. Now this is a zip file. You can fill up the molecular formula and the relevant details. You can see that at the end is your FOFCHKL. Here I got one more thing which has to be included. Now go to the REST file. Here the size of the crystal is not included, so that is a must. Size 0.35, 0.32, 0.28, then H tab, then bond $H, then confirmation. Now this size is very important to calculate the absorption coefficient, transmission factor. Save as INS, exit. Now refine. Okay, refinement is over. Now you can check the summary is converge. Now we can see the difference. Open this zip file. Now we can see here okay. So these are the information what is been given. Okay. So, like this one can complete the structure, you can use the past and the R-tape and the Pluto diagram, Mercury, all those things for completing your structures. Thank you for your patience. With this we will conclude the course. I will upload the consolidated summary in the due course. Thank you.